Just a little addendum to my video about Arduino's DS18B20s, respectively DS18S20 temperature sensors and the one-wire bus. Yeah, card link. In a video I did later about the one-wire bus, through the looking glass, that is probing it with the oscilloscope and down the rabbit hole, decoding, the bus on a bit level, I noticed, card link to that video too, I noticed that the DallasTemperature library I used in the aforementioned video does not really work with the DS18B20. Specifically, the command in the library to set the resolution, it does nothing, absolutely nothing. And so I was hunting for a library that would actually work in that respect with the DS18B20, and I found one. So here on the breadboard I have one DSB20 connected to my a newfangled Arduino Every, also card link. And by the way, that DS18B20 library and the one-wire library is working with the Arduino Nano Every. Anyway, I have here my DS18B20 sensor, direct powered. We will see why in a second. And it's converting away at 9-bit resolution, no problem. So if I heat that thing up, which is, quite hard because it's already quite hot in here, you see temperature is rising. And I'm printing also out the conversion time, which is about 85 milliseconds. Let's have a look at that newfangled library. Well, it's not that new, and the code. So here's the code I'm currently running, and of course, that newfangled DS18B20 library I'm using, and its real name is DS18B20RT, and it's by Rob Tillard. Link in the description. It also uses the one-wire library, of course. And if you know the old code, and you should watch the previous video, my DS18B20 is on pin 2, and I initialize a one-wire bus on that pin, and then I simply instantiate one of these DS18B20 objects with my one-wire bus as argument. And besides, in the setup, setting up my serial, I make a sensor begin, and that searches for exactly one connected sensor. So this is really a minimalistic library that is not as flexible as the DallasTemperature library, but it works for a DS18B20. That's an advantage. And then I do a set resolution. As you might remember, I can have 9, 10, 11 or 12 bits resolution with a DS18B20. And then in the loop, I basically request the temperature that's analog to the DallasTemperature library. And I take the time in millis when I did that. And then I wait for the sensor to complete its temperature conversions. We will have a look at the manual, at the datasheet in just a second. And this, polling the sensor, if it's completed its temperature conversion, it's only possible if you use direct power to the sensor. It's not possible when you use phantom power. And I'm also not quite sure, I would have to test that, if that library also works with phantom power. Maybe we'll do that afterwards. Yeah, and then I get the temperature from the sensor and print it out with 4 decimal places, and I also print out my conversion time. That is the time the sensor needed. And if we now, yeah, you saw the conversion time was about 85 milliseconds. So on average, if I change that to 10 and upload that to our Arduino. Okay, where's my serial monitor? It's gone. So we open it again. Yeah. You see, now it's needing 160 milliseconds and it's still working, and we get higher resolution. Yeah, a quarter degree C. And if I go to 11 bits, yeah, we can do that game for a while. Well, for 11 and 12 at least. And I open the serial monitor again, and we see, yeah, I get even not a quarter, but an eighth of a degrees resolution here. And it's still working. And we can do that for 12 bits too. And if I look now into the serial monitor, yeah, you see now we have a 16th of a degree C resolution. And it's still working. And you see the conversion time, basically each time it doubles. But we'll have a look in the datasheet after we took a look at both libraries. So that was the DS18B20 library in the version 3.8, and that's at least here the latest version which I used. And yeah, it can't set the resolution for the DS18B20. And I'm using now in a version only 01.5 the DS18B20 library RT library from Rob Tillett. And yeah, I basically showed you almost everything in the code about that library. It's really minimalistic. Yeah, one sensor per pin and asynchronous mode only. That is, you request temperature and then somewhere down the line you get your temperature. But that's okay. Let's have a look in the datasheet why that all is so important, at least for me. And there in the datasheet, yeah, under AC electrical characteristics, we find the temperature conversion time. We had a look in the previous video on that too. And on 9-bit resolution, so 0.5-bit degree C resolution, we need a maximum conversion time of 93.75 milliseconds, while, yeah, I won't go through the whole table again, at 12-bit resolution or 0.0625 degrees C resolution, we need a worst case conversion time of 750 milliseconds. And depending on your application, polling the temperature only every 3/4 of a quarter second might be too slow, and you might not need a full 12-bit resolution. Remember, the maximum error of that thing, at least in the temperature range from -10 degrees C to 85 degrees C, is plus minus 0.5 degrees C. So yeah, for many applications you are just fine with 11-bit resolution or 10-bit resolution. The problem with the DallasTemperature library is it's always stuck in the default, power on default of the DS18B20 of 12-bit resolution. That is, you cannot poll the temperature faster than every 750 milliseconds. And yeah, for me, that was an absolute no-go. I'm running my DSB20 now with Parasite power, and no longer a connection from the 5-volt pin to my 5-volt rail and the 5-volt pin is probably properly shorted out to ground, as you should do, yeah, according to the datasheet. You learn in the other video why. And you see all I get is 127.875 degrees C, which is an error value. So, yeah, parasitic power with that DS18B20 RT library, obviously not a thing. Let me just get that off here and connect my power pin again. Yeah. And we're back in business. So, yeah, no parasitic power with the DS18B20 RT library. So, that was my little addendum to my video about Arduino's DS18B20s, respectively DS18S20 temperature sensors and the one-wire bus. Till next time, bye.